I'd like to talk for a few minutes about duplication, uh, making two parts that look alike. And again, as you heard Bruce Danaher and I chatting here leading into this demonstration, most amateur turners and even a fair number of professional, so-called professional turners are into faceplate work. They want to turn bowls principally, or vessels. There's a second form of a bowl called a hollow form where you spindle turn it. But these are all vessels, and they're artistic, and I think they speak a lot to the fact that we all pull stuff out of our pocket, and it's the same stuff as a whole bunch of people around here have in their pocket. And suddenly you're going to make something totally unique that's different from everything else. So that appeals to people. But I somewhat quip at shows and symposiums that people brag about their artists and they never turn two things alike. And I joke that it's because they can't. So whether you're turning 4 spindles that look alike, 20 spindles that look alike, or 2 bowls that look alike, it is just as important with faceplate work that you can lay out and turn to what your conception is as it is in this type of work. If you can't do that, you really haven't mastered the craft. So I will speak some to faceplate turning today as well, and things that you can do to get these things all straight. Let's look at spindle turnings a bit. And as I mentioned, if you joined late, this is a job that just came in 10 days ago, and I finished it yesterday, but the person brought a hand drawing they made in, and it's for a piece of furniture they're building. And they wanted me to turn these legs. And these are kind of coming into rage today, this type of turning. It's common at places like Crate and Barrel and retailers like that who have gone back to these rather bulky early designs. They're really what you call mannerists. And in extreme mannerist furniture, there's tremendous difference between what's called the major diameter and the minor diameter. The minor is the smallest diameter wherever it is on the turning, but the major one is the biggest. And this one, the major diameter actually is the same here as it is over this big bead right here. And these will yet be drilled, and I'll do it by putting a drill in the headstock and pushing this into the tailstock to get a hole for this screw, which will attach it to the ottoman that they're building with a threaded nut. And that will put that on the axis. It also had to be turned so that these wheels or casters fit it perfectly. I'll zoom a little in on this so that you can see it a little better. But there it is, and you can see that it pretty well matches the drawing. The first thing I did was turn this out of a piece of scrap pine and then made sure it pretty much matches the drawing. Then I bring her on in a Zoom conference and we look at it closely and decide if it's good or bad. Back to the major and minor diameters, the first order of business is to mill a blank that you can make this out of. And so she actually had her cabinet builder make the blanks for me so that the wood matched the rest of it. And I really don't like to do glue ups, so I usually specify that, if possible, that the client supply the wood. So this is perfectly square, and being thoughtful, they made it quite a bit oversized. I would actually mill this just about to the size. This has a 2.5 inch major diameter, I believe. Yeah, 2.5 inches. So I would have milled this like 2 9/16, just over, so that as you brought that round, you're right there at that major diameter. And I don't have to do anything further. I don't even have to put a gauge on that really to check that it's correct. So milling blanks is very important. And if it's a long spindle, the blank should be jointed on its face and one edge, and then the parts cut from that to perfect squares. And this will get you the straightest blank that you will get out of that piece of wood. That being said, within a day or so, generally enough stress is in there and moisture changes and so on, that a spindle over about 18 or 20 inches will probably get some bow in it. And I showed in using a steady rest a while back how you can get rid of that bow by offsetting in the tailstock, bringing in a steady rest, and then resetting to the center. So you can overcome all these problems if you need to. We've covered milling. Let me clear this desk away. Let's talk a little bit about instruments that will help you to lay out properly. And I have a gaggle of them over here. We'll set all these out here for you to see. And believe it or not, in making this, I've pretty much used all of these a bit. And let's walk through them. The first is a good machinist square is always a good thing to have, but the best I think is Starrett, but Mitutoyo in Japan makes great ones. There's another one, Applied Engineering Corporation out in California, actually makes most of this kind of stuff for the house brands of Woodcraft, Rockler, Lee Valley, and you can buy direct from them, and they make extremely good products. They're not quite up to Starrett quality, but they're very, very good. One of the things you can get for your Machinist Square, you can often buy it in a set that'll have the square head, it'll have the center finder, and it will have a protractor head. But this allows you to quickly find the center of a square blank. It will also find the center of a round blank. You could hold this on the rim of a bowl blank and actually find the center with this tool. So it's very handy. Set those aside here. That's a 12-inch. You can also get 6-inch squares. I use a 6-inch square a lot on the lathe. Also very handy is an automatic center punch. Once you get that center, you simply put this down and go like that, and it has a spring and a plunger in there, and it puts a nice little detent that you can find your center on. That way you can load and unload your lathe running. It saves a lot of time. It's not dangerous either. So this is a Starrett. They're about $60 today. You can actually get a pretty decent one on most tool walls of a box store for like $15, $20. And for most people, totally adequate. Now, two other things that are very good for layout are dividers. And even if I bring it in from measurement and a print, a divider, when you make beads and coves, can help awful lot to get these absolutely equal size. So I have a gaggle of dividers, and these are a pair of Starretts, very nice dividers. These are various ones. I've picked all of these up at yard sales, house sales, and flea markets over the years. And where they're $25 to $75 new today, you can still find them around for 20 bucks a pair probably at yard sales and so on. The next item are calipers, and they run from big to small. This is a very old set that I keep in my antique toolbox that probably dates to 1875, maybe to 1900 somewhere. And of course I have small ones that are handy. And it's almost better to have ones that aren't the same size and look the same, because as you're duplicating, you can go from your biggest to your smallest diameters under the major diameter and just use a smaller set of calipers every time. And this allows you to keep track of them a heck of a lot better. One other thing is that for metalworking, the leg of that caliper will come out to a very sharp edge. And for metal, which you never turn at the speed of wood, and it's generally smoother than a piece of wood, the sharp edge is actually better for feeling that you're really getting the size you want. But if you put that on a wood turning, it will grab it and throw it back at you in a dangerous occurrence. If you buy some of these, it's okay, go ahead and buy them, but you just take them over to a grinder and you grind this off to a nice little radius, and then you take a little stone and you polish that edge so that you can use this as a wood caliper and not hurt yourself. Marking gauges are also very handy. If you know, for instance, you're going to make a pommel on a leg at a certain distance from the end, you can just set this up and quickly put a scratch line in there. You can intensify that with a pencil if you want, but you get every one exactly the same. Let's talk about rulers for a minute, measuring devices. I like steel rulers very well. I have them up to 36 inches long. And being originally trained as a machinist, I tend to go to very accurate rulers made by people like Starrett, or this is this Applied Engineering 2-hook rulers from them. This is a it's Shawana, it's a Japanese company. Woodcraft sells this brand. And it is a machinist ruler, and it is graduated in 64ths and 32nds on this side, but 50ths and 100ths on this side. This can be very handy if you're translating from prints, because you can, if it has a decimal amount on it and not a fraction, you can just transfer decimals directly from the 100th side. I use hook rulers all the time, and hook rulers have a little hook on the end that you can bring this to the end, so you're getting absolutely registered on the edge. And especially if you have a chamfered or radiused edge, this gets you much more accuracy, and then you can transfer down here. Satin chrome, very readable. That's a 18-inch one, And here's a 6-inch one that I generally carry in my shirt pocket in the shop. Let's talk a little about workflow. For a turning this small, you really don't have to think very much about it. You're just going to turn it from one side to the other. But still, I'm going to work from the biggest dimensions to the smallest, because every time you take something out of that piece of stock, it gets a little weaker and a little wobblier, and you start to get vibration in the piece that will make this not as easy to turn, and you'll have to sand more sometimes to get vibration out if you don't have other techniques that'll get rid of it. It's good to remember that the diameter of a turning, the stiffness or resistance to buckling gets stronger by a power of 4 as the diameter increases. So a very little difference in diameter can make an awful lot of difference in how much flexing you get in that turning during the process. On things like chair legs or table legs, where you could be out as much as 30 inches, and a lot of those can be done without a steady rest, but still working sort of from the center of the turning to the ends and working from the center to the big end first and then the center to the smaller end makes a lot of sense, and it'll get you there with a lot less hassle and a lot faster. Any questions on anything I've covered so far?
We're still here with you.
You all right? Any texted questions?
No.
All right.
I have a question for you.
Sure.
I'm a primitive reenactor, and I'm only here to get educated. I've never done any of this. On the square blocks, would you cut a fresh log to use as a block and dry it for 6 months, or would you use it green?
Green turning, if you go on our YouTube channel, Conover Workshop's YouTube channel, you will find in the playlist for all the articles and videos, I've done the videos mostly in that playlist, for Woodworkers Journal magazine, which I've been writing for 9 years, every issue. You will find a YouTube video on riving or working from green wood. It was a common practice up to probably 1950. It still survived in spots, but you basically split the piece out of a log and then put it in the lathe and turn it right away. It will go slightly oval, but not enough that will affect the visual appearance of the piece.
All right. Thank you very much. I'll look into that further.
Ernie, your camera went to sleep.
Yeah, I'm shocking it awake here. The other one you can disable timeout. On this one, it won't go more than, I think, 15 minutes. Did it come back? No. All right.
There you
All right.
go.
You're back.
There we go. Now, let's talk a little bit about layout. In most of the kind of turnings, I either produce a print myself or these days I tend to do it in SketchUp, which is a CAD program, free incidentally, and there's tutorials that will allow you to start using that in a few hours, but it's a good program to download. The free version, you can only use it for your own use. You can't do anything that you sell, copyright. But at any rate, this person did a nice job of drawing this out, but they've made some mistakes. First of all, you always want a center line, which is...
Excuse me, Ernie. So
Yep.
you're just a little bit out of focus right now.
Oh, yeah, I see. Thank you.
Looks like the inside of a pocket at midnight.
Yeah, well, it's easier to unplug the camera and do it off the back screen when you're focusing than it is to look across the room at a computer. My real hope eventually is to have a monitor here, which would be big and I could see everything on, but one step at a time. But at any rate, very handy in any drawing of this type. You usually put a center line, which is a long and short dashed line down the center. But I did take her drawing over to the bench and I taped it down so that it was parallel to the bench. And then I took a square and just brought all those lines out to the edge so that in the lathe, I can just hold this up and pretty well find all these lines. So this piece of paper is fine for 4 turnings. I could probably do 10 off a piece of paper, but it would get pretty shop worn if you were going to do 20 or 30 turnings. So generally what you do is draw it out and then tape or glue. I use rubber cement this to a piece of like 1/8-inch plywood. And then you can cut that down the middle, or you can extend lines out to the edge. Say you'd put the edge about here. Either way works. And then you can even cut little notches with a jackknife in the edge or a scroll saw. And you can then put a pencil in that notch and hold that up to the turning while it's spinning in the lathe and put a mark on it pretty easily. And that storyboard becomes very handy. I like to do the whole turning with bringing the edge with a notch in it. And then I can take a set of calipers and very quickly set it to a diameter that I want without having to fool around with a ruler. And additionally, you can then store that storyboard on a peg on the wall or a nail and keep it for future reference should you ever want to make that part again. So storyboards are very handy. Let's go on here. I think at this point, probably a practical demonstration of all this put together by turning another one of these parts might be the best thing we can do. And I will do this at about the speed I normally work. Now, one other instrument I'm going to show you that if you do a lot of this kind of work, it's probably worth having, and that's a Gilbert Caliper. And this has a V-block with a plunger here. And when you put that, against the piece, you can see this scale here comes up and it tells you what diameter you have. It is pretty darn accurate. It's an amazing piece, but it is really handy if you do a lot of this. Designed by a Windsor chair maker. So we're going to make sure this clears the wrist.
Say, Ernie, excuse me
Yes.
again, but we're getting a real good view of your tailstock. In other words, can you just shift the camera over a little bit?
Yep. That's because we moved the tailstock. That's about the sweet spot.
That's where we want to be.
Thank you. This is live theater. All right. I'm going to start out with a roughing out gouge. Anybody that's watched any of my videos and stuff know that I work with extremely long bevels in all my spindle turning, that you can see how darn long this one is. At this point, I'm going to start to feel it come around. I can feel that I'm now round. And again, if I'd have milled this to a 32nd over the major diameter, I'm there. I wouldn't have to do anything more. With this piece, unfortunately, that's not the case. We're going to have to set it to the 2.5-inch major diameter. This is again where these steel rules are awfully handy, that you can put the end like that on the end of the ruler and see that there I'm at 2.5 inches. And now to actually get that, I'm going to take a tool called a beaning and parting tool. This is 3/8 of an inch wide, and again, ground to a very long bevel.
Do you have any idea what the angle is of that bevel?
Well, it's double-sided. I'd say it was somewhere around 25 degrees, 30 at the most.
What I use.
Now, the spinning work will actually pull a pair of calipers at the last minute over the work. So you want to do this until they sort of dropped over without being affected by the turning work at all. Let me grab something across the shop here. One part of duplicating spindles is often that you have to turn tenons on the end of them, many of them, and you want them to fit a drilled hole. And so this tool, in combination with a common end wrench like this, you can use that as a caliber right here, and you could bring this right down and get a 7/8 inch that would be a press fit with a drilled hole every time. And if you have 3/8 of an inch, if you wanted a 3/4 tenon, you just make 2 strokes of this. You don't have to lay out anything. You just once, twice, the wrench drops over it, you got a 3/4, 7/8 tenon, just like that. All right, we'll now remove that material. Now, just for your information, I've turned enough that I do lean on these tools a little. Most people would be more like this and a little bit afraid. I can feel the bevel and I'm actually leaning on it. I don't look at the tool itself very much. I'm mostly looking at the horizon right here to see that I'm straight and even. I don't make it any smoother than that. There's no reason to. I'm simply going to get out this storyboard. And I just hold it up like this. You can see the rest of it there, but I'm going to put it right there. And I'll make this mark, this little bead right here. This point right here, and I'm going to put these two edges in as well. Now, I like to use about a 2B art pencil, which is quite a soft pencil, so you want to be sure you drag it like that, like it's a scraper. And you do not have to go all the way around the work. You just need a line long enough that you're going to get enough persistence of vision to make this look like a line. You see that we have a clear line there. Now, I believe I mentioned before that I like to set most bead sizes with a set of dividers. And if you look there, my divider measurement, which is set to this, right there like that, is actually about a 32nd bigger than the pencil line. So you do get more accuracy in your beads. And people will not see big differences. That you have to get a pretty big difference between diameters before people start to cry foul. But if you don't have all of these elements the same width and at the same height on the turning, they will yell foul pretty fast. So getting all this stuff lined up on a turning about the same is pretty important. I'm going to go in with a skew and just mark that bead, which I'll cut right from the get-go. And again, my skew has a pretty fine edge on it. Now, here's my Gilbert caliper. You can actually take this. I want to go down to 2 1/4 right in this area. And I'm put a little chamfer right there. bring my tool rest a little closer, and I'll roll this bead. All right. We now have to come down right here and create this bead and this whole area through here. This is a tricky cut right here. And so we'll do that next. If we look on our print, we want to be at 1.5 inches in diameter either side of that bead, which again, Mannerist style turnings have a lot of difference in diameter between the two sides, or between the major and the minor. So getting out a set of calipers here. This is set to 1.5 inches. I'm going to open that up to about 1 5/8 inches, which theoretically would be the diameter over the top of that bead. And now I'll take a parting tool . When you first do a few of these, it's almost scary how much difference in diameter there are between the extremes and of the thing. Now I'm going to go in with a skew and put a little incised mark on either side of the bead. And it's gouge work from here on out. This is actually a little less than diameter right in there. And this one is just a bobbin that rolls in from this side. I could actually go to a larger gouge and put more muscle into the cut. Nice. Back to a spindle gouge, and we'll roll the bead. Nice. All right. I believe this is 1 3/4 inches. So we'll just open up our calipers a little bit. That's 1 3/4 inches. Back to our beading and parting tool. We're going to just center right on that pencil line. Good. Now back to a 1/2 inch spindle gouge. And I'm going to reach down there with my soft lead pencil and put a line right in the middle where that edge right there will be. So this is a little more complicated. This is the other end of the bobbin. And so we're going to remove wood up through here. And we're going to actually cut a cove in this area. And now one nice clean cut right up through here. We'll make it 2 nice clean cuts. Now, if you were feeling sporty, you can always make that cut with a skew chisel, which will put a very nice finish there. But I seldom use a skew to do something like that. First of all, sandpaper will straighten out anything that's wrong with that in a few seconds. And if you screw it up with a skew, you're trying to make money here. You're going to lose a lot of time. All right. So basically, this is that diameter for the rest of the turning. We're just going to take this wood out of here. All right. Now, yes, sir.
On that bobbin that you just turned, do you got any advice for us turners that don't have the skill level that you do in terms of making that shape consistent from one item to the next?
Yeah, that's one is your eye. Again, I look more here at the horizon than I do down here what the tool's doing. I'm feeling what the tool is doing. And secondly, as you can see, let me change cameras here. Let me make that camera live again.
I was just wondering if you use any kind of profile template or something to...
No, I never do. But you can see I have this up here sitting right there. Often, part of the things on the 3520B when John Arnie and Barry Schwager and I worked on that design, is we added a thing we called the comparator, which never was very popular, but it was a set of centers. You could put the turning right here and it would be the same place as in your lathe, and you could just compare them. You can hang it on a couple of pieces of string, or make some kind of little stand you put it on, but having the part here like this to compare will help an awful lot to get that consistent. In fact, to be honest, I would like to see a little more this be neck down. I don't think it's quite small enough, but in a demonstration like this, the show kind of needs to go on. So where did I put the pencil? There it is. All right, so we got actually a double bead here, which was added to the design. And we got a small bead here. All right, I have all the information I need. Here's our double bead. There's our high point right there. And I often put a little, just a curve there to show me that. And here's the bead leading into the foot. So back to our lathe here. I'm actually going to make this a little bit more extreme down through here.
Can you move back to the close-up camera, Ernie?
Oh yeah, I'm sorry. That's about all the further I can go, but that smoothed that out an awful lot. Now, my diameter is 1.5 inches again right here. So I will set the calipers again to about 1 5/8 inches. There we go. Now I'll go in with a skew and I'll nick either side, which are the edges of those two double beads, and then I'll nick the center. And you notice I didn't measure anything, I did it by eye. All right, and this one goes. Now, very important in spindle turnings in this kind of work is the diameter has to be the same on either side of those beads. If you get one side larger than the other by very much, it'll look like you put a rubber band around the turning and squeezed it in, and it doesn't flow. So you want to be careful of that, to adjust that as you turn these beads. So I'm doing that right now. I'm just turning these beads. Now, I'm a little smaller from my view than I am here, so I will adjust this side just a trifle. And this should come down a little faster.
Camera shut off,
Yep.
Ernie.
Nice. Now we just have that one. And I actually took my two smallest set of calipers. And this caster is actually a taper inside. So I have this set to the big end of that taper and the small end. So I will just go right in here like this. And I'll take the other pair, drop them in the sawdust. And I'm actually now going to take this where the bead is and bring that down to an 1/8 inch greater in diameter than where the foot is. Now I just need to get rid of all this wood right here. And this is why I like a square grind on a roughing out gouge, because I can roll that and I can actually come up and touch this shoulder without catching it. All right, we're almost there. We're going to turn the other side of this, which is really a big half bead. Now we'll make this bead. First time I ever did that. Good enough. Now I'm going to do a heel cut right up through there. And I'm actually going uphill, but in this maple, I'm getting away with it. And I'm going to put a little chamfer right here so that when I test this fit, I'm not going to hang up on a corner there. I can now just swing that up. It's a little tight. By rocking that, I can feel I'm right here, but I'm too big there. So I'm also using what's called a step center. The center of this center is spring-loaded so that by just releasing the tailstock, you can stop the work and examine it. Very handy for this kind of work. And I'm too big at the base. If you really want to get, oops. If you really want to get two tapers to match perfectly, smearing this with chalk and then turning the piece on, it'll tell you where to remove material. There we go. A little bit loose, but not bad. This is live theater. Now, a final thing that'll make this look much better is come back to every one of these beads and go right down in the root of it with a toe of a skew and incise the edge of every bead. The difference in how it catches the eye will be quite remarkable. You can see how that we have defined edges. I will sand this bead. It's got a little bit of a hard spot in. I'll sand that out. About 5 minutes with sandpaper and this thing will look pretty swell. And the client probably won't ask me how much I use sandpaper, if I'm lucky. That's sort of the plan here. I might mention a little bit about faceplate turning and duplication. One thing you want in any faceplate turning is that it meet the shape you envision. So it's often good to make a sketch of what you want to turn. And that was the turning. It wasn't a tool. I was lucky. So getting these walls fairly consistent is handy, and there's all kinds of gizmos people sell. This is a fairly cool one that you can put these two balls in here and you can see how it changes with, you can see the thinnest part of that rim is right about there. It's calibrated to 1/8 of an inch. It's really good, works very well, but it's, I don't know, 75 or 80 bucks probably today. About as good, it'll work just as well, is just to take a piece of 1/8 inch welding rod and bend it around till it fits your need. And by putting this against the inside of the bowl like this, I can run this right down here, and watching that gap, I can tell how consistent my wall is. So that's a very inexpensive, precision measuring tool that will be very handy. And of course, it would do a very long, deep hollow form by simply bending a different configuration on this. So that's a very good way to measure on any kind of vessel. Also, again, cutting this blank, if you're making a whole set of salad bowls, cutting all your blanks to exactly the same diameter, finding exact center when you chuck them, all of this makes a tremendous difference in the consistency to which you can work. Questions on anything I've covered here today?
Yes, Ernie, the storyboard, did the customer give that to you in the actual size, or did you blow that up yourself?
No, she sat down at her desk and did this exactly to what she wanted. And we talked it over. I think she's doing quite a bit of this kind of work, so I may give her a little lesson in mechanical drawing one of these days. But she did a pretty darn good job, really, of this is to size. And then once I turn a sample from that, we agree that it, is what she wants, and we go from there. So no, and again, anybody can do this. A good material, if it's a big leg or something fairly long, is to use a piece of shelf paper. Just roll it out and use that as your drawing paper.
Right.
Hey, Ernie, do you have any suggestions on proportions that work best for design? I guess we've all seen what appear to be bad turnings, just from a design standpoint. They're just kind of wacky looking. And I'm wondering if there's any guidelines around design that you like to use.
Well, going back and looking at anything the Greeks and the Romans did will never fail you. But one problem I think most beginning spindle turners have is they're afraid to do anything definite. And a good spindle turning, you could actually cut this at any one of these little lines with a zero kerf saw and reassemble the thing, and it still would have some visual, identity. So you want to be very definite between starts and stops. You want to have nice curves in all of these turnings that are consistent. And there's often in any of these turnings, like Windsor chair legs are a great example, that you have the leg tapers up to a bead, usually about 3/8. Then you have a bobbin above that, and then you have a smaller bead and bobbin above that, and it's really a recapitulation of the larger shape. So keeping all of that consistent with the same lines. Going to museums, looking in books and looking at what's worked in the past, I think is really good. And you can then euchre that into a new design if you choose to do that. So that, I guess, would be my take on that. But I don't know. Some people just have that. My father had that. He could just take anything he did really looked right. He had the right lines in it and the right everything. I've struggled with that all my life. But I do think that looking at what works for other people is probably a good start. Any other questions here? In the little picture, I threw in the mass email for this little session. I had a picture of all the parts I turned for a what's called a great wheel, a spinning wheel that I made for Susan in 2014. Two friends of mine came and we made 3 of those in the shop. One collects spinning wheels. He's out in Eastern PA and had an extant example of the spinning wheel, which if you look at that picture, the center of it looks a little like a cannon barrel. It is the only great wheel I've ever seen that what you call the table, that's the piece of wood everything sort of is attached to, was a turning also. Usually they're just like a board that they drill holes in and put all the legs and everything in. So we all thought this was a pretty neat piece of spinning equipment. And so we took that example and we made 3 of those in, and it took us like 7 days to make them. We worked 8 hours a day and sometimes more at night. We steam bent the rim, and I made a video as we went along, and that's on our YouTube channel. It's something like building a great wheel. And then there's another one, Test Drive, in which Susan actually spins on it and makes it work. It was made in Bradford, Ontario, the original, which is where Alexander Graham Bell comes from. And the gentleman that made those made quite a few of them. And they're known for that part of Ontario. But it was a lot of fun. The hub of that is a very precision piece of work, and it has 10 spokes coming out of it, and that's sitting in that picture. And I actually laid that out with dividers. It's in the video, and the test drive is fun. I go a little bit further on that wheel, and that mostly the original, not mostly, all the originals had a bearing that at best was brass, but it usually was antler or bone, either which works pretty well as a bearing. And of course, the spindle would have been forged. I used a piece of 1/2-inch drill rod, which is precision ground and very smooth. And I used needle bearings, which I hid in the hub. You can't see them, but they sure make it spin good. In fact, it spins so good that it'll go to low spots or heaviest. I made another one years ago in which I balanced that wheel by putting lead weights in the ends of the spokes until I got it to spin and stop, no matter, and just stop where it was. But Susan said that was a waste of time, so I didn't bother with the second one. Well, I've enjoyed this session today.